This motor lost a phase, and the system shut it down immediately. But in a real-world scenario, many motors do not stop instantly, especially if they were already spinning due to inertia or mechanical load. The motor can continue running even after losing a phase. And that's where the real problem begins. Even though the motor is still rotating internally, it starts operating under unbalanced conditions. The remaining phases draw higher current, the motor loses torque, vibrations appear, overheating begins, and eventually the windings can become damaged. That's why industrial automation systems use phase monitoring relays to detect phase loss, phase sequence reversal, or phase imbalance. That's why industrial automation systems use phase monitoring relays to detect phase loss, phase sequence reversal, or dangerous voltage imbalance before the motor is destroyed. The moment a phase loss occurs, the relay activates. All right, let's first build the self-holding circuit. We add a push button, a switch, another push button. Or rather, let's start with the power supply. Now we place a normally open contact, and then the relay or contactor. For the stop function, we use a normally closed push button. We'll label the contact as KM1 and associate the auxiliary contact with KM1 as well. Good. Now let's add a three-phase motor. Here we have a three-phase power supply. Since we want to simulate a phase loss, we'll place switches on each phase to emulate that condition. In this case, we'll use normally closed switches. Next, we add the contactor contacts. We won't add overload protection for now because this is only a test. Our goal is to demonstrate something else. So, let's test the three-phase motor. Simulation time. We still need to link the contactor so that this three-pole contact becomes dependent on the contactor coil. The self-holding circuit works perfectly. If a phase is lost during the simulation, the motor shuts down. But as we mentioned earlier, in real life, if the motor already has momentum, it can continue running. The motor becomes self-induced, generating excessive current, overheating, and vibration, which means we need to protect it. That's why we use a phase protection relay, also known as a phase loss relay. This relay does not directly interrupt the power signal. That's important to understand. It only monitors the phases. Depending on the model you purchase, phase monitoring relays can also supervise phase sequence. If two phases are swapped, the relay detects the sequence reversal and alerts you. That's extremely important because many machines rely on the correct direction of rotation. Reversing the phases can reverse the motor's rotation direction, potentially damaging equipment, affecting production, and causing serious issues. So using this type of relay gives us a double layer of protection. Now at this point, the relay is not actually doing anything yet. It's only monitoring the phases, but it's not performing any control function. Besides monitoring, the relay can also indicate which phase has been lost through its status indicators. However, the contactor is still closed, meaning it continues allowing current to flow through the remaining two phases. For proper operation, we need to add a normally closed contact here and associate it with the relay. Here is the phase loss relay. I named it PFL. Look at what happens. Actually, this needs to be a normally open contact. Let's change it. In this case, the relay output remains activated as long as all phases are present, right? We still need to link it properly. Now we associate it with the phase loss relay. Done. Phase loss relay connected. We start the system. The relay detects all three phases. The contactor is not active yet. Then the phase loss relay activates and keeps the control circuit enabled. It doesn't interrupt it. I press start, the system self-latches, and everything works perfectly. The moment one phase is lost, the circuit opens. The system unlatches, the contactor drops out, and now the remaining two phases are no longer allowed to continue feeding the motor. This is how protection is achieved, both when a phase is lost and when the phase sequence is reversed.